Hi everyone, welcome back to the Microsoft in 29 days self-paced course. In case if you have still not registered for this course, so make sure to register for this course. You will find the link of this course in the description of this video. And this course is absolutely free of cost. Once you register for the course and you click on the start button for this particular course, then you will get access to all the 29 days that are there. And on each day, we solve two problems. Like if let's say I click on day 2, so you can see that you have two recorded problems, two recorded editorials that we solve as classwork. You can see here. And apart from this, you will get access to solving 5 problems. Why 5 problems? The 2 problems that we do as classwork. Other than this, the 3 problems that I give as homework for every topic. So make sure to register for this course if you haven't already. And try to solve the questions, because you can also see yourself. You can see your progress amongst other people through the leaderboard. Okay. Now, let us discuss this problem, that is first non-repeating character in a stream. So the problem says that given a input is stream A, right? So basically they are saying that they will give you a stream, like basically a stream is coming one by one. So characters are coming one by one. A stream of characters is coming one by one. And what you have to do is, the task is to find the first non-repeating character each time a new character is inserted to the stream. If there is no non-repeating character, then we have to put -1 for that particular point of time. So let us quickly discuss the sample test case to get things more clear. If we will discuss this particular case here, suppose that the input given is like A, B, C. Okay, so this means that first of all the character A will come. So suppose when the character A comes, so like is there any which is the first non-repeating character when the string is A, when the stream is A? So in that case the answer would be what? The answer would be nothing but A only, right? Suppose that we have A and A. So after we have A and A, so we can say what? Like for this A we already had A. Now for this A, for this particular position, we can say that there is no non-repeating character, right? Because A is repeating and there is no other character which is occurring single number of time. So in that case, we will say that we will print a hash. Okay, the problem statement says that if it is not, then you will print a hash. You can see here. In this case, if there is no character that can be appended, so in that case you will add hash to the answer. Okay. After that, when we get A, after that A is there, so the answer for this part is A hash, right? Then B comes. Suppose in the stream B comes, right? After that B comes. So when B comes, so which is the non-repeating character in this stream? So I can say that the first non-repeating character in this stream is nothing but B. Okay. After that, suppose we consider the case where we have A, B and C. So when we get A, B, C, in that case what will happen? If we get A, B, C, in that case we can simply say that A hash B was already there, then which is the non-repeating character here? So I can say that B is also non-repeating, C is also non-repeating. So in that case we will say that which is the first non-repeating character? So that is nothing but B. So in that case I'll write the answer as B. So let us check out the final answer for this. You can see A hash BB. That is the answer, and that is what we are getting in the end as well. A hash BB. So this is the final answer that we get. So if we think that B was also the non-occurring single occurring character, non-repeating character, C was also the non-repeating character, but here we inserted B. Why instead of C? Because B was coming earlier than C. So I need, if there are several characters that are non-repeating, so I need to return the first non-repeating character for that particular position. So I will say in this case, when I think of something like first, right, when I think of something like first, which came first, character which came first or integer which came first, which data structure comes to our mind in this term? So we can say that we simply think about the first in first out kind of concept, right? Because B was coming first, so we directly put a B here. So in that case first in first out concept is there. And which data structure tells us about the first in first out concept? You can pause the video and think. Obviously it is nothing but the Q. Okay, this is nothing but the Q. Q will help us to determine the first in first out, right? It will always give us the access like that. In this case, if let's say we have another input, suppose we have ZZ. Okay, so suppose we had Z. Okay, we had Z. Okay, we had Z. So we will get the stream as ZZ. Suppose first of all we get Z. So in the Q, what we will do is, in the Q we will insert Z. Okay, then we will say that okay, Z is there, right? Z is the single occurring character because it is frequency is 1. Then what will happen when we insert Z and Z after that? So in this case, when we insert Z, so we can say that Z is now occurring 2 number of times, okay? So we'll remove this Z, and after that we see this character. So again this Z is occurring 2 number of times. So basically after Z we will insert a hash here, right? So that is the case here that we have to observe in this part. Now in this case, in these cases, what we need to think of is we need to have the frequency for every character first of all. So let us quickly first of all copy the sample test case that was there. So the sample test case was nothing but AABC. Okay, suppose the case was AABC. In this case, if the sample case was AA, then B and then C. Okay, so I need a frequency. I need a frequency for counting the frequency of all the 26 alphabets, because it will consist of only lower case letters, right? So in this case, first of all, what I will get is I will get this A. Okay, so I will increment the frequency of A by 1. So suppose I am doing indexing 0, 1, 2 up till 25. Okay, up till 25 is what I will do, up till 25 index, because there are, if there are characters occurring, so if I do A minus A, so I'll get nothing but 0. Okay, if I do B minus A, so I'll get nothing but 1. So 0 will represent A. Similarly, B will be represented by 1. And if I talk about Z, so Z minus A will give me nothing but 25. So Z will be represented with the 25 value. So that's what I can store in an integer. So that is why I do not need to take a map or anything, any data structure like that. Now the next thing is that what we will do here is we will also make a queue. Okay, we will also make a queue. So initially inside the queue we will insert A here. Okay, and we will increase the frequency of A by 1. Like, so frequency of the 0, like this character, that is A, because 0 will indicate the frequency of A. So we'll increase its frequency by 1, and after that we'll start iterating. So if we check out this particular character, so is the like current top of the queue, I will check current front element of the queue. So is the current front element of the queue having just frequency 1? Yes, it is not having frequency greater or equal to 2. In that case, I'll simply add it to my answer. Okay, then what will happen is we reach to this particular character A again. So we will insert it inside the, we'll first of all push it inside the queue, and then we'll increase the frequency of A with 1 more. So A's frequency increases to 0. Then what happens if I check the front element of the queue? So front element of the queue is this A, and it is having frequency as 2. So it is not a single occurring character, right? It is not the, it is a repeating character. It is not a non-repeating character. So in that case, I'll remove it from the queue first of all. Then again, if I check, so at the front of the queue, I have this A. So if I check for this A, so what happens in this? If I check for this A, so this A is also repeating because it has the frequency as 2, correct? Because A had the frequency as 2. So I'll remove this from the queue as well. Now if I see, so the queue becomes empty. So in that case, for this particular position, I'll put a hash, because I'll say that, okay, for this particular position, there is no non-repeating character. And you can see that because for A string, there is no non-repeating character for this particular stream, for this much of this part of the stream. Then I'll get to B. When I get to B, so I'll increase the frequency of B by 1, okay, and I'll insert B into the queue. After that, I'll check what is the top element of the queue. So top, like front element of the queue, if I will check, so front element is what? Front element is having the frequency as 1. So it is a non-repeating element. So in that case, since this is the first non-repeating element, because I'm using a queue, so if there were several characters other than this, so since this is the first character that is present in the queue which is not repeating, so I'll directly write it. So after this, I'll write B here. Then I move to C. The moment I move to C, so I will say that, okay, let's increase the frequency of second position by 1. So that means we are increasing the frequency of C by 1, and then we'll insert C inside the queue as well. Okay, after this, when we have inserted C inside the queue, so we will check for the front character of the queue. Front character is B, is if it has frequency, if the front character several number of, if it has a frequency of greater or equal to 2, in that case I'll remove it from the queue. Otherwise I will insert it into the answer. So if I see for this B, so this B is having what? This B is having the frequency as 1, which says that it is the non-repeating character. And if I see it in this stream A B C, so in this case till this point B is the first non-repeating character. So in that case, simply the front of the queue is what I will add to the answer. So I'll add B to the answer as well, right? That is what I will do. Let's say that if we had any other cases, suppose that instead of this, what we had was, we had another case. Let's say we had A, then we had B. Okay, suppose we had C, then we had B, then we had C, and then we had A, and then suppose we had another A. Okay, suppose this was the string that we had. So initially we had this character. Okay, we'll also have the frequency array. Suppose the frequency array is for 0, 1, 2 up till 25, correct? For all the indexes, I'll have a queue as well initially. And what we will do here is we'll first of all go to the first character. So first character is A, so I'll increase the frequency of A by 1 and insert it into the queue. After that, when I check, so the front of the queue is having the frequency just 1, so I'll not remove it from the queue, and I'll add it to the answer as well, right? I'll add A to the answer. After that, what we can say here is, let's move to the next character. So we move to A. So this much stream is what we are talking about. In this case, we can say that frequency of A gets updated to 2. Now when the frequency of A gets updated to 2, then second A is also inserted inside the queue. Now I check for the front element. So front element A is having the frequency as 2, so I'll remove it. Then I check for the next front. So this is also having the frequency as 2, so I'll basically remove it. And after this, after several removal, if I'm coming out, so either I'll come out because the front element is a non-repeating character, or because of the queue becomes empty. So in this case, I can see that the queue becomes empty. In that case, if queue becomes empty, so I'll directly add a hash to it. Okay. After that, when I come to this B, so I'll increase the frequency of B by 1. So this is increasing and B gets inserted. After that, when I check for the front element, so the front element is not a it is a non-repeating character. And since this is a queue, so the front element will be the first non-repeating character of the current stream. So I'll simply add it to my answer. Then I move to C. When I move to C, so I'll increase the frequency of C by 1 and I'll insert C into the queue. After I have inserted C into the queue, so what we can observe is, suppose this was CB, right? So after I have inserted C inside the queue, so what we can observe is that the front of the queue is having a B. Okay, so we are talking about this much part of the stream. Okay, so we can see that C is also non-repeating, B is also non-repeating, but we will directly insert B here, right? Why? Because we can say that B is the first non-repeating character. Okay, after this we will go to this position. When I go to this position C, so the frequency of C gets updated by 1, so it gets updated to 2, correct? After this, what happens? I will insert C inside the queue as well, and then what will happen is, we'll have like the front of the queue is a single, like front of the queue is B, which is occurring single number of times. So it is a non-repeating character. So I will say that, okay, it is the first non-repeating character in the current stream, this, which is this. Okay, A B C C. So in that case, I'll directly write B here, and then I'll go forward. So when I go to this character, I'll increase the frequency of B by 1. So B's frequency increases to 2. I'll insert B inside the queue. After that, when I check the front element, so it is having the frequency as 2, so I'll remove it from the queue. Then I'll check for the next front element. So C is also having frequency as 2, so I'll remove it from the queue because it is having frequency greater than equal to 2, which makes it a repeating element. Then this C also I'll remove, this new front also I'll remove. Then I'll remove this B as well. So that means my queue becomes empty after certain removals. So in that case, I can say that for this particular position, the answer would actually be hash, because if we are talking about this particular stream, so in that case, you can see that A is also occurring 2 times, B is also occurring 2 times, C is also occurring 2 times. So there is no non-repeating character. Then what happens? We move to this A. When we move to this A, then we insert A and we increase the frequency of A by 1. So again, we see the front element. So when we see the front element, which is A, so it is having the frequency greater equal to 2. It is having actually the frequency is 3, which means it is a repeating. So I'll remove it, and when I remove it, so there is no other element inside the queue. So in that case, I will say that, okay, if the queue becomes empty, so I'll insert a hash for it. Okay, then what happens? I will have A here. When I get A again, so I'll increase the frequency of A by 1, so A's frequency becomes 4. When the frequency of A becomes 4, so I'll insert A into the queue. Okay, now A's frequency is greater than A's frequency is 4. So in that case, I'll simply return a hash, like I'll simply store a hash, because I'll be removing A from the stream. Why? Because I'll remove A from the queue because it is a repeating character. So that is what the answer I'll get, right? You can observe this part. So let us now write the code for this approach. You can easily observe that in this particular approach, we are basically inserting the elements into the queue one by one, and we are checking if the front element is a candidate. If it is the first non-repeating element, so we are directly adding it to the answer. Otherwise, after several pop operations on the queue, if the queue becomes empty, we store a hash for that particular position till that particular point for the stream. Otherwise, we store the character, the first non-repeating character, because we are using a queue, so it will always give us the first non-repeating character because it implements the concept of first in first out. Let us now try and write the code for this approach. So what we will be doing here is, we will be first of all having this string that is given to us. So let's first of all name this string as S. Okay, so I'll take out the size of this string. So let's say size is n dot size, s dot size, int n is equal to s dot size. So I'll take out the size of this particular string. Then what we need is, we also need a vector that will store the frequency. So I'll say that vector int, let's say the frequency for all the 26 characters, because I will be storing them from index 0 till 25, right? So I'll initially mark the frequency as 0, and in this case I also need a queue which can store the characters of the given string one by one. Okay, I also need an answer, so I'll declare a string answer initially as null. Okay, after this we can simply say that we can start the iteration for the string. So I starts from 0, I is lesser than n, and then we can do an I plus plus. Okay, we can do what? We can simply push the current character of the string into the queue. Okay, after this part is done, so we can increase the frequency of the current character by 1. So current character is s of I. If I want to have the mapping as 0 to 25, so I'll subtract a from it, as I said, then I'll increase the frequency of this particular character, okay, in the string. Now what I need to check is, I need to check that I need to do something. So you will say that, okay, you will write if the queue size is greater than 0, okay, and the queue and the frequency of the element at the front of the queue, right? If the frequency of the character at the front of the queue, okay, if it is greater or equal to 2, in that case you will say that, okay, we need to pop it out. But will we do it just one time? No, we can do it several number of times until the queue is having some elements inside it. So in that case we will not write a if statement, we'll instead write a while statement, okay, because we will might require to do it again and again for several characters that are repeating. Okay, after coming out of this loop, if the queue dot size, okay, if it equals to 0, so in that case the queue becomes empty. In that case we can simply say that to our answer we will simply add the hash value. We'll simply add the hash for this particular position because there is no non-repeating character currently. Okay, all the characters are repeating. Else, otherwise, we will simply insert the front of the queue. Right, we'll simply add the front of the queue in our answer because that will be the character that will be the first non-repeating character in the current string. And then we can simply say that we can return the answer that we have stored. Let us try and compile this code to see if there is any error. Okay, so you can see that we are getting the same output on the samples. Let us quickly submit this code as well. So you can see that our solution was able to pass all the test cases. In case if you understood this explanation, so make sure to hit the like button and comment down understood as well. Thank you. In this video, we will discuss the problem minimum cost of ropes. The problem says that there are n ropes given which are of different lengths and we need to connect these ropes into a single rope. So basically we'll be given an array which will represent the length of n different ropes, and what we need to do is we need to connect these ropes into one single array, and the cost of connecting two ropes, suppose there's a rope with size 1, size A, and there's a rope with size B, then the cost of connecting the rope 1 with rope 2 will be nothing but A plus B. Okay, so the task is to minimize this cost. So let us quickly check this sample input for better understanding. So if we talk about the sample input, first of all, suppose n was given as 4 and we were given the array value as 4, 3, then 2 and then 6. Okay, so we have to do what? We have to merge the ropes in one by one in such a way. We have to every time at every step we will keep on merging two ropes each, and we have to minimize the cost. And suppose we are merging 4 and 6, in that case the cost will be nothing but 4 plus 3. Okay, so this is the cost for one time, and we have to see that when we get just single ropes, and then what is the overall cost. So let us say that if we have 4 and 3, if we join them together, so the cost will be 4 plus 3 is equal to nothing but 7. So I'll get a rope of 7 length, right? I'll replace this 4 and 3 ropes, rope of 4 length 4 and rope of length 3 with a rope of length 7. Okay, and the cost for this will be 7. Then 7, 2 and 6 are there. After that, suppose I add this up, so I add 7 and 2. So if I add the rope with length 7 and with length 2, so the cost for this operation will be nothing but 9. So now 7 comma 2, the rope with length 7 and the rope with length 2 will get replaced by 9 because that is the overall added value, and then I'll have 6 as well. Okay, after this part we can observe that we have a rope with length 9 and another rope with length 6. So what we can do is, let's say we do 9 plus 6, so we get what? 15. So this is the cost. So now if finally we can see that we will get a rope of 15, let's say. So if I add the cost up, so what will I get? I'll simply get from if I see here, so 9 plus 7 is nothing but 16. Okay, and 16 plus 15 is what? 31, which is higher value. Okay, can we get some other values as well? So in this answer we can see that we got 31, but suppose if we add using some other way. So if we add it using some other way, so suppose what we do is we first of all add this 2 and then 6. Okay, so 2 plus 6 will give us 8, so the length of the rope will be 8. So 4 comma 3 comma 8 is what we can write. Then suppose that we add this 3 and 8. Okay, so in that 8 and 3, so 8 plus 3 will be nothing but 11. So we'll get a rope of 11 length, and we have 4 here. So 4 plus 11 will give us 15, right? So we'll get finally a rope of length 15. If I now add the cost up, so this will be nothing but this, and this value 11 plus 15 is nothing but 26. And if I see 26 plus 8, So that will give me nothing but 34, which is again very high. So previous answer 31 was better. But can we get a better answer? Yes, we can get a better answer as well. If you will observe what is the motive of the question. The motive of the question is to minimize, right? Is to minimize the cost, right? We have to minimize the cost. And if we want to minimize the overall cost, so I can say that for minimizing the overall cost, the cost at every addition should be reduced. And if I want to reduce, like, because if there are some additions that I'm doing, right? If this is one operation that I'm doing, in the second operation this is the cost, suppose in the third operation this is the cost, then I'm adding this to an overall cost, correct? So every operation's cost is what I should bring down. I should try to bring down the cost of every operation such that the final answer will also be down, or will be minimum as possible. So for this, what we can say is, if we want to keep the cost minimum, so we can try to do what? We can try to add the minimum ropes at every step, right? If we add the minimum ropes, two of the smallest length ropes, in that case the cost will be what? It will be minimum as it can be. So in that case, what I can say is, I can say that let's add first of all 3 plus 2. If I add it, I'll get 5. Okay, so the cost here will be 5. Then you have what? 4, 6, like 4, 5 and 6. Now what are the two rows with minimum cost? So I can say that length 5 and length 4 ropes are there, which are smallest of in terms of length here. So I will add them up. So the cost for that will be 9. So 9 comma 6. Now I just have 2 ropes, so I will directly add them. So 9 plus 6 will be what? It will be 15. Now if I see the final answer, so it comes out to be 15 plus 5 is nothing but 20. Okay, so if I overall add it, so 15 plus 5 is 20, 20 plus 9 is 29. That is the cost that I am getting, and the final answer is 15. Okay, so I am getting a final single rope, and the cost for that is 29. Why? Because at every step, at every addition of 2 ropes, I try to choose the 2 of the most minimal length ropes. So for this, what can I do? Can I think of some data structure that will help me to get access to the minimum elements of the array? Yes, there's something known as priority queue, right? So it is an enhanced form of a queue only, but basically I can use a priority queue, or you can say a min heap, which will keep the minimum elements at the top. So I'll take out the minimum element first of all, then I'll take out the second most minimum. Like after I take out the minimum element, then the heapify process will be there. So now inside the queue, whatever elements are inserted, so out of them the new minimum will be at the top, so I'll take it out as well. So every time I'll take out 2 elements, 2 of the most minimum elements, right, out of it, and then I'll remove them. And after removing them, I will add, and whatever the new result is, I'll add it into the queue, and I'll add it into the cost as well. And I will keep on doing this with the min heap or the priority queue till the time we have at least 2 elements inside the priority queue. If the priority queue just has 1 element, so that means that the rope has been made and I can simply return the cost. Otherwise, I'll keep on doing this particular operation. So let us try and write the code for this. So what we'll be doing here is, first of all, we will be given the array and we'll be given n. So first of all, we'll declare the cost. So let's say long cost, because they have given long. So we'll write long cost is equal to nothing but 0. Okay, initially we'll mark the cost as 0, and we will declare a priority queue, which will be for the min heap. So we will declare a priority queue long comma. This is the template in C++. You can follow it in Java as it is in Java. So vector int comma vector long comma greater long. Okay, this is the template for declaring a min heap, right? This is nothing but a min heap that I have declared in Java, like in C++. Okay, after this, what we can say is, we will simply iterate through this particular given array arr. Okay, and then we can simply insert all the elements of the array into the priority queue or the min heap. So we can say that priority queue dot push will simply push what? The ith element of the array. After we have done this, so we have the cost as 0, right? So we will run until the queue size is greater or equal to 2, right? If we have at least 2 ropes inside the priority queue, then we will add them up, right? So first of all, I'll take the first rope. So let's say I take long a is equal to nothing but pq dot top. Okay, I take the top element out, that is the minimum current minimum rope, and I'll pop it out from the queue because I want the heapify process to happen in log n time, so that I can get the second most smallest rope currently. So I'll get int b long b is equal to nothing but priority queue dot top, and once I have the access to it, I'll pop it out from the priority queue. Okay, after this part is done, so what is the new length? So the new length c will be nothing but a plus b. Okay, and now what I will do is I'll simply push it. I'll push this new length new length rope into the priority queue, and I'll also add it to the cost. So cost plus is equal to C, because the cost for adding a rope with length A and the rope with length B is nothing but A plus B, which is stored in C. So C is equal to A plus B, so I'll add the cost in this. Okay, and after this, if we just have one rope remaining in the priority queue, then we'll simply break out of the loop. Okay, we'll simply terminate. So we can simply return the cost here, which will be storing the minimum cost to connect all the n ropes so that we can make a single rope. Now let us try and compile this code to see if there is any error. You can see that our submission is giving 29, that is the sample output. Let's try and submit this code as well. Okay, so it gives us a wrong answer somewhere. Why does it give us a wrong answer? In this case, if we see, so we are getting a shorter answer than this, because maybe I might have missed something. Yeah, I have taken int, but I should have taken long. So the data type was wrong. Let's now submit this code. So because of overflow, we are getting a wrong answer, but now it will get accepted, I think. So you can see that our solution was able to pass all the 281 test cases that were there. And talking about the time complexity of this code, since you know that if the heap is of size n, so it takes log of n time for the heapify process, for the insertion and deletion process. Every time it takes log n time, and since there are overall n elements, so it will take n log n time for doing this. So the time complexity of the code will be nothing but order of n log n, and the space complexity will be order of n, because we are storing all the ropes of all the n ropes inside the priority queue initially. In case if you understood this explanation, so make sure to hit the like button and comment down understood as well. Thank you.